Welcome back. Now we're attaching the weapon, and this looks great, but we're attaching as soon as we overlap, and we'd like to attach manually with the press of a button. So to do that, we're going to need another action mapping. So let's go to Edit and Project Settings, and scroll down to Input. And here are the action mappings. We just have Jump. We can add another action mapping for when we'd like to pick up a weapon. Now we can add a new action mapping by pressing the plus icon, and I'd like to call this Equip. And we need to decide on a key for equipping items, and I'm just going to click the keyboard icon and hit the E key. I think E is a great key for equipping weapons as it's right there next to the W key, and we're using WASD to move around. So now that we have an action mapping, we need to create a callback function to bind to this mapping. So let's head back over to our Visual Studio project, and we'll add this callback to /character. So here in /character.h, we have our axis mappings here, and I'd like to make a new one right at the bottom of the protected section. This will be a void function, and we're going to call this eKeyPressed. That way we can use the E key for different things. Now this is an action mapping, not an axis mapping. And action mappings don't have that float input parameter. That's because these are one-off functions that get called a single time when we press a key. So we can go ahead and create a definition for eKeyPressed. And we need to bind this to the action mapping. And we do that in SetUpPlayerInput component. So scrolling up to that, here's SetUpPlayerInput component, and here's an example of binding a function to an action mapping. We can follow this example and simply copy this line and paste it here. Now we need to change it a bit. We want to change this from the jump action mapping to the equip action mapping. And we need to change our callback function as well. We want to call our new function eKeyPressed. So I'm going to copy that fully qualified function name and put it here, being careful not to get rid of the address of operator, as bind action requires the address of the callback function. So now when we press the E key, our eKeyPressed function will be called. Now, what we want to do is attach a weapon if we're overlapping with one, which means our system needs to be architected a little bit differently. We have our weapon class, and on-sphere overlap is simply attaching the weapon. But now we want to do this a little differently. I'd like to have a variable on the character class that stores the overlapping item. And I'd like it to be an A item, as we might be overlapping with different types of items, not just weapons. So in /character.h, I'm going to add a private variable, and this will be of type A item, which means I'll need to forward declare the item class. So we'll do that up at the top. We'll say class A item, and now we can use the A item type, and we'll add a new A item variable. So we'll add this at the bottom of the private section. It'll be A item, and I'd like to call this overlapping item. And if this item is set, then we know that we're overlapping with an item, and we can try to pick it up. Now I'd like this to be a uProperty, as it's a good idea for our pointer variables to be uProperties as long as they're derived from uObject, and of course actors are. And I'd also like to see the value of this at runtime. Now I'm only concerned with seeing the value on the instance of our character in the world. So to see it in the details panel, I can give this the uProperty specifier visible instance only. And we won't see it in the details panel for the character blueprint, so we're not cluttering up that blueprint. We'll only see it in the details panel for the instance of our character that exists in the world at runtime. So now that we have an overlapping item, we need to be able to set this from the item class once we overlap with an item. So since this is a private variable, we can't set it directly from the item class. We'll need to have a public setter function. And I'd like to keep my setter functions and getter functions in their own public section down at the bottom, just to keep things organized. So I'll make a public section down here, and we can make a setter function for overlapping item. it can be a void function called setOverlappingItem, and it can take an aItem pointer as an input, and we'll call this simply item. And we can define this all on one line right here, and all this needs to do is set overlapping item equal to item. And now we have a public setter for this. Now, it's a good idea to keep these simple setter functions inline. An inline function is a little bit more optimized. You see, every time we call a function, the flow of execution has to jump to the function definition, where that function body is defined. For example, in our /character class, we're making calls to functions, such as get control rotation here and move forward. When the flow of execution reaches this line at runtime, it has to jump into this function, wherever that function is defined. But if this function were inlined, then at compile time, the compiler will go and find the function body and copy those lines of code and paste them right here. So at runtime, those commands will be executed directly without this indirection of jumping into this function, finding its location in memory, and reading those lines in that function body. So inline functions are a little bit more optimized, but we should only do these with small, simple functions, typically getters and setters. Now in C++, the inline keyword is used to inline functions, so we would say inline right here. But the inline keyword leaves it up to the compiler to decide ultimately whether or not this function will be inlined. The compiler can choose not to inline any given function. But Unreal Engine has a macro to force the compiler to inline a function. And that macro is force inline. So if we mark this function force inline, we're guaranteed to get it to be inline. And this is a good practice when creating our getter and setter functions. So we'll do that here. So now that we have a setOverlappingItem function, we can set the overlapping item from the item class in onSphereOverlap. So in item.cpp, in onSphereOverlap, instead of printing a debug message, I'd now like to set the overlapping item on the character, which means we'll need to cast other actor to a /character. And to do that, we'll need /character included up here at the top of the item.cpp file. So let's include that. It's going to be in characters /character. Now you'll notice that Visual Studio will put a backslash when selecting from the pop-up that it provides us with. That'll work, but I'd like to keep them all forward slashes to be uniform. So now that we have /character included, we can cast to a /character in onSphereOverlap. And we'll do that here. So we'll make a local variable of type a/character. That's going to be a pointer, and we'll call this /character. And we'll set this equal to the result from a cast to the a/character type. And we're casting other actor. So after this cast, we should check /character to make sure it's not a null pointer. So if /character, then we'll go ahead and set the overlapping item on the character. So we can say /character set overlapping item. And we need to pass in a pointer to an aItem. Well, the item we're overlapping is this particular item we're in. And we can always get a pointer to the instance of the current class we're in with this. So that's what we'll do. We'll pass in this. Now, as soon as we end overlapping with an item, I'd like to set that overlapping item pointer back to a null pointer. And that way, as soon as we walk away from the item and we're outside that sphere component, we can no longer pick it up. So we'll use these lines of code down in onSphereOverlap. But before we do that, I'm going to remove this line where we're getting the other actor's name, as we're not using that anymore. So I'll copy these lines here and paste them right into onSphereOverlap, replacing what was there before. And we're calling setOverlappingItem, but instead of this, I'd like to pass in null pointer. And as you should know, the null pointer keyword is a pointer that points to nothing. So now that we're setting the overlapping item, we can now leave it up to the character to take care of actually attaching the weapon. So if we go to weapon.cpp, we see that onSphereOverlap results in attaching the weapon's item mesh to the character's mesh. Instead of doing this in onSphere overlap now, I'd like to make a function that does this. So here in the weapon class in weapon.h, I'd like a public function. So we'll make a public section right here at the top. And this function will be a void function, and I'll simply call this equip. Now, if we're going to take care of equipping the weapon, we need to see what we're going to do. So we know we're going to need the slash character, or at least the slash character's mesh component, since we're going to be calling attach to component. In fact, attach to component simply needs a uScene component. It doesn't even need to be a skeletal mesh. And we also need to know the name of the socket as an fname. So what I'd like to do is have these as input parameters to the equip function, a uScene component and an fname for the socket. So in weapon.h, we'll add an input parameter of type uScene component, and we'll call this inParent, just like in the attach to component function. And we're also going to have an fname called inSocketName. So let's go ahead and define our public equip function. And here in the equip function, we're going to do what we did here in onSphere overlap. We're going to create an fattachment transform rules using snap to target and true. And then we can call attach to component from our item mesh. So we'll take item mesh and call attach to component, and the scene component can be inParent. We'll use transform rules for the attachment rules, and we'll pass in inSocketName for the fname. And now we don't even need to do a cast to slash character anymore. We'll go ahead and remove these lines of code here. So now we have a function that can handle the attachment. We want to call this function from the character class as soon as we press the E key. So let's go back to slash character, and we'll go down to our new callback function, E key pressed. Now, we only want to attach the weapon if we're overlapping with an item that is a weapon. So we'll need to check that overlapping item, and we'll need to see if it's a weapon. Now, there are multiple ways to do this, some more efficient than others, but for now we'll take the naive approach and simply take our overlapping item and cast it to a weapon. That's going to require us to include the item and the weapon header files. So we'll include those at the top here. We'll say include items/item.h, and we'll also include items/weapons/weapon.h. And I'll go ahead and change these to forward slashes. And in E key pressed, we're going to cast the overlapping item to the A weapon type. So we'll say A weapon and call this overlapping weapon. And we'll set this equal to the result of a cast to A weapon, and we're casting overlapping item. Now, overlapping item could be a null pointer, and if it is a null pointer, then we're simply casting a null pointer to weapon, which will fail, and the cast will return null. So we can simply check the value of overlapping weapon to see if it's null. We'll say if overlapping weapon, and if we make it inside this if check, we know we're actually overlapping with an item which cast successfully to a weapon, so we know that this is a valid weapon. And then we can call the weapon's function equip, passing in the scene component, which will be our character's mesh, and the socket name. So we'll do that here. We'll take overlapping weapon and call equip, passing in our character's mesh, and we're here inside of slash character, which means we have access to the getMesh function. Now, the next input is an fname. We'll create a temporary fname with the string right hand socket. So if we press the E key while we're overlapping with an actual weapon, then we'll call equip, and the equip function will attach the weapon's item mesh to our character's skeletal mesh at the right hand socket. So we can hit save all and hop back into the editor, and I'm going to close project settings and go ahead and do a hot reload. So after hot reloading, we can test this out. I'm going to press play. Now, as I mentioned, I'd really like to see the value of overlapping item just to verify that it's being updated as we're playing the game. So I can do that by searching the outliner for slash and finding BP/character. And now I can see the details panel for this instance of my character in the game. And I exposed that overlapping item variable to the details panel with visible instance only. So if I search for overlapping item, I can see it here. And since it isn't initialized with any meaningful value, it's set to none. This is kind of like a null pointer in C++. Now I can click in the viewport to gain control of my character and walk up to the sword. And as soon as I do, notice that overlapping item now has a value. It's set to BP weapon. And if I walk away from the sword, it's set back to none. So there's our on-sphere overlap and on-sphere end overlap functions at work. And we see that it updates in real time. So that's great. And if I press the E key while overlapping item is set to none, nothing happens. But if I walk up to the sword and press the E key, it's now attached to my hand. So it's working as expected, and this is great. Excellent job. So now we're actively picking up the weapon using our action mapping called equip. And this gives us a great deal more control. In fact, we can pick up any type of object that is derived from the item class. All we have to do is go into our E key pressed and find out what type of item we're overlapping with and decide what to do from there. Now, this is one way to do it, and as I mentioned, there are more efficient ways that don't require us to do this cast to a weapon, and we'll discuss those in the future. Awesome job. I'll see you in the next video.